Chemical bonds, Chapter 20 in the book, Stability and Bonding. Recall that electrons are negatively charged and repel other electrons, whereas protons in the nucleus are positively charged and repel other protons. However, protons and electrons are attracted to each other. Hence, chemical bonds are combinations of repulsive and attractive forces. We're going to talk about bonding today, covalent bonding. When you discuss bonding, you talk about the number of electrons because electrons are the ones that determine if an atom will bond. Specifically, it's the number of electrons in the outermost electron share, also called valence electrons. First level holds 2 electrons. The second level holds 8 electrons, whereas the third energy level, also called orbital, holds 8 electrons, and the fourth energy level holds 2 electrons. This is that rule 2882. And this is true for the first 20 elements in the periodic table. After that, it gets quite a bit more complicated. We're assuming it's a neutral atom, meaning that the number of electrons equals the number of protons. The shells fill from the inner to the outer shell. So that first one gets 2, the second one gets 8, third one gets 8, and the last one gets 2. And again, this is for the first 20 elements in the periodic table. I want you to practice creating these diagrams of the electrons. We're not worried about the nucleus when we talk about bonding. We're concerned about the electrons. So let's go ahead and practice with oxygen. And look at oxygen in your periodic table. Find out how many electrons, assuming it's a neutral atom, so the number of electrons is the same as the number of protons, and how many electrons does oxygen have. Now draw the nucleus, draw the first shell, and then whatever left, put into the second energy shell. If anything's left, make a third energy shell. Go ahead and try that now. Now let's try aluminum. Go ahead and pause. This is what aluminum looks like. Notice it has 2 in that first energy shell, has 8 in the second energy shell, and it only has 3 electrons left, and those are in that outer electron shell. Facts to know. Atoms with full outer electron levels are very stable and do not form bonds. Bonding is how unstable atoms become stable. Atoms can gain electrons, that's called an ionic bond, lose electrons, that's also called an ionic bond, and it can share electrons, and those are called covalent bonding. Just to let you know, when we talk about compounds, it means 2 or more different elements joined together chemically. That could be joined together through covalent bonds. Those are called molecular compounds. It can be joined together through ionic bonds, such as salts. And then the third major bond is metallic bonds. There are some other minor bonds, but the 3 major bonds, actually the 2 major bonds, are covalent and ionic. Atoms seek to fill their valence electrons. They either attract more electrons, again that's ionic bonding, give up electrons, again that's ionic bonding, or share electrons, covalent bonding. A molecule is specialized. You need to know that a molecule is a compound that is covalently bonded. A molecule is 2 or more atoms covalently bonded. Make sure you get that covalent bonding in there. Covalent bonding could occur when the outer valence electrons, outermost electrons, are shared. It generally occurs when you have non-metallic elements. And the electrons are not always shared equally. When they're not shared equally, you have what's called a polar molecule, one that's slightly positive charged N and a slightly negatively charged N. Now, I want you to try it out. I want you to pause, and I want you to write what H2O may look like. So what you're going to do is draw an oxygen molecule, just the electrons for it, and then you're going to draw 2 hydrogens sharing the electron. Now the reason I've got the positive and the negative there is because the oxygen, being the bigger molecule, actually hogs the electrons. So it's more often at the oxygen than it is the hydrogen. And so the hydrogen has this almost naked looking proton that isn't being surrounded by the electrons, and so it has a polar positive charge. The electron, which is negative, isn't neutralizing it as much as it should. The positive and negative neutralize each other out. In this case, that's not happening. It's more in the oxygen. So oxygen is more negatively charged. The hydrogen molecules are more positively charged. Another way to draw electron configurations instead of doing that messy board-like diagram is just to use Lewis dot diagrams. It's a diagram that only utilizes the valence electrons. The Lewis dot diagram is used to show covalent bonds. You draw the atoms only with their valence electrons as dots. You group these dots in 4 possible pairs around the symbol. So lithium only has 1, and you can see its dot right there. Where if we go over to something like neon, you can see where it's got 1 pair right here, 1 pair right here, 1 pair right here, and another pair here. It has 8 total, which neon has 8 valence electrons. Now what I want you to do is pause and create the Lewis dot diagrams for period 4. So let's go ahead and do some review. Non-metal to non-metal bonding is generally covalent bond. That's when non-metal elements react with other non-metallic elements. They share electrons in order to obtain that magic 8 valence electrons. That is covalent bonding. Here we have fluorine and fluorine. It combines. How many electrons does one fluorine atom need to reach 8 valence electrons? Well, if it has 2 together right there, 2 fluorine atoms right there, it should look like this. You see the one right here, you see the other one right there, and then when you combine it, and they're using different colors here just to show, you combine it, this one fluorine atom here is going to go circle here and circle here and circle here. It goes back and forth, and both of them do that so often that it appears as if this fluorine atom right here has 8, but it also appears that this fluorine here has 8. And the shared electrons, the ones that are just right here, they are unshared. They are not being passed back and forth. Those are called lone pairs. So Lewis dot diagrams can show combinations of atoms. You can use it for one atom. You can use it for a combination of atoms. Complete structure will have all electrons paired. In other words, you'll have an octet around each atom. Otherwise, you're going to have a molecule that wishes to combine with another molecule yet to get to its 8, magic 8. You can also use Lewis dot diagrams to predict multiple bonds. So let's look at oxygen for an example. Let's go ahead and draw the Lewis dot diagram for a single oxygen atom. How many electrons are needed to satisfy the octet rule? Go ahead and pause. Now draw a second oxygen atom. Instead of a dot, use a small X for its electrons so you can tell which goes to which atom. Lastly, we'll combine them. How might they share electrons to have a full 8 electrons? This is what you might have come up with. Carbon dioxide. 2 oxygen and 1 carbon. That 2 after that letter means that you have 2 oxygen. Okay? So you've got 1 carbon and 2 oxygens. How would that be combined? Like that. Sometimes you don't want to draw dots. Sometimes it looks a little nicer if you draw a line instead. So instead of doing these dots, I could have erased that and put a line instead, just like we have down here. Here's some more examples. Notice how much cleaner it looks with the dashes instead of double dots for the bond. For additional information, I highly recommend this site right here. It has an excellent interactive flash description of Lewis dot diagrams, covalent compounds, and you can enter them and it'll tell you if you do it correctly or not. It's just a wonderful, wonderful site. Well, I hope you've enjoyed this and I hope you've learned quite a bit. It's very dense. Please go back and view it as many times as you need to. And after we've done some more labs, go ahead and review it again. You may pick up some more information. Enjoy.